All right, everybody. Let's take a look at day 2 for graphing trig functions, specifically sine and cosine. Today is going to be about horizontal transformations. So continuing on in standard form, we're going to talk about two other things that we can do to our graph and what they would represent and where they would be located in our standard form of our function. So this time it's both going to be like kind of inside the trig function, if you will. All right, all of these values in here, we're taking sine or cosine of that. So what b is going to represent is b is going to represent the number of times that the graph will repeat itself in the normal period. And it's essentially going to change the period of my function. The new period can be found by doing 360, that would be the original one, divided by whatever that value is for b. So for example, if it was a 2 right there, that would be a compression. All right, it's kind of going to take our values and compress them inwards. If I did 360 divided by 2, it would be a new period of 180. And then addition or subtraction inside by x is going to be a phase shift, which is just a horizontal shift. We use the term phase shift specifically with trig. And the important thing here is to think opposites, just like we've been doing before for any functions that we've dealt with. So if you see a plus c, think that you need to move to the left by that value, and a minus would actually shift us to the right. All right. So let's take a look at some functions here. So it says name the phase shift and or period change from the parent function. Well, all I have going on right here is a minus 180 degrees. There was no number being multiplied, so the period is still the same. All right. Period would still be 360 degrees. But I have a phase shift here. So the phase shift, thinking opposites, is going to be right 180. In my next example, I've got cosine of 3 times x. So this is going to be a period change. And in order to find that new period, I will do 360 divided by that value of 3. And 360 divided by 3 is going to give us a value of 120. So my new period would be 120, a much shorter cycle. In this one, it says name the amplitude and transformation. Mr. Allen did not change the words here before I printed it. We will do the new period and also phase shift. So my new period is going to be 360 degrees divided by 1/4. And so when you have a value of 1/4, it's actually going to stretch it out. 360 divided by 1/4 is same as 360 times 4, which would be 1440. So it is going to take a long time until this cosine function repeats itself. That is a very long period, if we think about what we're used to, which is 360. And I do have a phase shift here. My phase shift, it has a plus 90 there, so that will go left 90 degrees. Again, always thinking opposites for those phase shifts. So let's take a look at a function here that's got a phase shift and what this would look like graphically. All right. So when I think of graphing sine and my normal x values that I would want to use, I would normally go 0, 90, 180, 270, 360, but all of these need to be shifted to the left 90 degrees. So what I'm actually going to plug in here is I'm going to use x value of negative 90, 0, and then keep going from there. Now, by shifting all of those values to the left 90 degrees, all of my y values will stay exactly the same. So sine starts at 0, goes to 1, 0, negative 1, and then to 0. So what I need to do here is just label my y-axes, and my x-axes here. So I'll go from 1 to negative 1. And let's go ahead and plot these points. So my first point is at negative 90, 0. And then my next point is at 0, 1, 90, 0, 180, -1, and 270, 0. Again, a little strategy that you can do here on your top and bottom. Just put little curves there. Makes it easier as you are connecting. Alright, so if I take a look at my graph right here, I had a phase shift to the left, 90 units. And, you know, like roughly, if I think of like where my parent function would be, my parent function would have been something like this in black. And so you can see, like, if I were to just pick this up from my maximum point right here and slide it over to the left, 90, that it would match up and the graphs would be on top of one another. Let's take a look at another example here. So this time I have cosine, and this time I have a minus 90. So this is going to be a shift to the right, 90 units. So once again, instead of thinking of, you know, my normal values of 0 through 360, let's take all of those and let's add 90 to those, since they are being shifted to the right. So I'll go from 90, again, sorry for the phone, 180, 270, 360, and 540. And then my cosine values start at 1, go to 0, -1, 0, and back to 1. Again, just thinking from the parent function. Let's go ahead and label everything down here. I'm going to pause the video while I do that and also plot all of these points. Alright, so after labeling both my axes, x and y, and then plotting the points that I had from my table here, you'll notice that it was, you know, shifted to the right 90 units. And if I needed to get some other points here, I could just continue this pattern. You know, so I'd be back down to 0 here and -1 right there. And not too hard in order to, you know, just continue these points to the left if I needed to start at the axes right there. Let's take a look at another one right here, sine of 2x. So this time I have a period change, right? So what changed? Well, that would be my period. And my new period would be 360 divided by 2. So my new period is going to be 180. All right. So when I have a new period here, well, here's what's going to happen. Now, if I think of my original values, going from 0, 90, 180, 270, and 360, essentially I'm just going to divide all of those by 2. So 0 divided by 2 still be 0. 90 divided by 2 is going to be 45. 180 divided by 2, 90. 270 divided by 2 is 135. And at this point, if you're noticing that instead of increasing by 90 for all of these coordinates, I'm increasing by 45s, and I would end at 180. Now, all of my y values will be the same from the parent function now that I have adjusted the x coordinates here. So sine starts at 0 and goes to 1, 0, -1, and 0. So let's go ahead and label our axes like so. So I'm going to just use the markings that are here. And so I need to count by 45s this time. And so what this does is, you know, by deciding the scale on here, if we were to compare this to like the parent function, it's not going to necessarily look shrunk, but because we have a new scale here on the axes, it definitely will be. So let's go ahead, 0, 0. Let's go from 1 to -1 on my y-axis. 45, 1, 0. And now let's connect those. Yeah, I've had better this area, not the greatest. All right, but there we go. All right, next one. I've got cosine of 1/2. So I have a new period. All right, and that new period will be 360 divided by 1/2, which essentially means times 2. So again, if I think of my original values that I'd have here for x, 0 through 360 by 90s, this time all of them are going to be times 2. So 0, 180, 360, 540, and 720. Now because that is the only transformation I have here, will be all of my regular parent function values for cosine. So starting at 1 and going down to -1 and back up. So now once again, like before, all I need to do here is just label my axes appropriately. So instead of going by 90s like I have in the past, this time I will count up by 180s. So I'll go 180, 360, 540, 720. So 0, label the y-axis also. Go ahead and plot your points. So I'm going to pause the video while I do that. All right, so here we are. Got everything plotted. Again, make sure that you end the graph with arrows because it will continue infinitely in both directions. All right, let's take a look at the last one here where we're going to do both of these together. All right, so I have a phase shift where I've gone to the right, again, always thinking opposites. So I'm going to go right 90, but I also am going to have a new period. And that new period is going to be 360 degrees divided by 2. So that would be 180. Now, as I make a table of values here, there's a couple of things that I'm going to do. So first, I'm going to go to the right 90 degrees. All right, so that means instead of going 0 through 360, I'm going to go 90, 180, 270, 360, and 540. But now, because I have a new period, I'm going to take all of those values and divide by 2. Essentially, my period will be halved. So this will go 90, and it will become 45. This 180 will become 90. 270 divided by 2 is 135. 360 divided by 2 is 180. And 540 divided by 2, well, let's see, I just add 45 to that. 225. Wait, what the heck? Ladies and gentlemen, I'm back. Mr. Philpott had a little moment here. 360 plus 90 is 450, not 540. And half of 540 will be 225. So all is good. All right. And now my sine values, again, are going from 0 up to 1, then back down, and ending at 0. All right. So I'm going to go ahead and label my axes here. So it looks like I just need to range from 1 to -1. So the y-axis will be pretty standard. And then I will go by 45s for my x-axis. So I'll go from 45 up. And it will allow all of these to be plotted here. So 45, 0, 90 will be at 1, 135 at 0, 180 at -1, and 225 at 0. Go ahead and connect those. And if I needed to graph a couple other points, again, just continue that pattern. All right. Thank you, everybody.